All right, continuing on with 10.1, we're now looking at quotient property of square roots. For any real numbers a and b, where a is bigger than 0 or at least 0, and b is also at least 0, the square root of a over b is equal to the square root of a divided by the square root of b. So it looks something like this. The square root of a over b is the same as just applying that square root to the top and the bottom. Square root of a over square root of b. Now you can use this property and our other properties of square roots to rationalize the denominator of a fraction that has a radical. This involves multiplying the numerator and denominator by a factor that would eliminate radicals in the denominator. Now again, I'll show you what that looks like in some of our examples here. So for example 7, we have 4 square roots of 6 all over 2. Now I'm going to show you one way to deal with that. We would just break it up like we did before and call it 4 times the square root of 3 times the square root of 2, because 4 times the square root of 6, well, the square root of 6 is 3 and 2. And it's still all over 2. Now, like with any of our fractions, if we have all of this in our numerator over something in the denominator, and these are all just being multiplied, we can always just cancel out any like terms from the top and the bottom, which means we'd be left with 4 square roots of 3. Because at the bottom, we've lost all our factors, so it's like it's over 1. The top lost that square root of 2, so it's just 4 times the square root of 3. Now another way you can look at that is square root of 6 over the square root of 2, we can consider 4 times the square root of 6 over 2. Now 6 over 2, 6 divided by 2, is just 3. So it's 4 times the square root of 3, or 4 square roots of 3. You can think of it either way. You can deal with it however you want to do it. Either way, in the end, you should get a simplified answer of 4 square roots of 3. So let's look at our next example, example 8. We need to simplify 3 square roots of 8 over 2 square roots of 12. So I'm going to do it similar to the first one that we did, break down the top and the bottom into smaller pieces. Now 8 I broke into 4 and 2, and 12 I broke into 4 and 3. So we have 3 times the square root of 4 times the square root of 2, all over 2 times the square root of 4 times the square root of 3. Now, anything we see on top that can cancel out anything on bottom, square root of 4 and square root of 4, that'll make our life just that much easier. Now we can't cross out 2 and 2 because this is a square root of 2, and this is just the whole number 2. Same thing, whole number 3, square root of 3, so we can't cancel those out. What we do need to look at now is getting rid of this square root of 3 in the denominator. Now how would we get rid of something from that denominator? Well, we'd multiply the top and the bottom by that square root. Whatever it is down here that we need to get rid of, that's the square root we need to multiply by. So square root of 3 was down here, so we need to multiply a square root of 3 over square root of 3. When we do that, notice that square root of 3 times another square root of 3, that'll become 3. So our bottom is now 2 times 3. Because 2 was here, square root of 3 becomes 3. Now on top we have 3 times the square root of 2 times the square root of 3. So it looks something like this. At this point then, we have 3 in the top, 3 in the bottom, so those can cancel out. And we can combine square root of 2 and square root of 3 into the square root of 6. So on top we have the square root of 6, on bottom we just have 2. And at this point, this is as simple as we need to make it. In fact, it won't simplify anymore because we have all whole numbers in the bottom, no radicals, and there aren't any fractions underneath this square root symbol. It's just the square root of a whole number 6, and that won't break down any smaller. We can break it into square root of 2 and square root of 3, but we can't simplify those two square roots. We don't know the square root of 2. We don't know the square root of 3. So square root of 6 over 2 is our most simple form for that radical expression. All right, for example 9, we need to simplify 2 square roots of 3x to the 4th all over 4 square roots of 6x. So breaking down the top and the bottom, We have the 2 that we had from before. 2 goes here. Square root of 3 goes here. Now this x to the 4th, I'm breaking into x squared and x squared. Now again, like some of our previous examples, I'm doing that because now I can say that cancels that out, that cancels that out. So we don't have to deal with those. Okay, on bottom, we have 4 times the square root of 2 times the square root of 3 times the square root of x, because 2 times 3 times x makes this 6x. Now I can also start canceling things out. Square root of 3 matches with the square root of 3, so those will cancel out. We don't have to worry about them. On bottom, though, I have this square root of 2 and this square root of x. So I need to multiply the top and the bottom by the square root of 2. That's what we see right here. And I need to multiply it by the square root of x. The reason we did this is so that this one matches with this one. This one will match with this one. And then everything is taken care of. So this is what it'll look like afterwards. On bottom, we now have 4, it's right here. 2 goes right here, and that was this one and this one. X goes right here, it was this one and this one, and that takes care of everything on bottom. Now on the top, we still have this 2, it's right here. X is right here, x goes right here, square root of 2 goes right here, and square root of x goes right here. Now again, we can cancel some things out. 2 will cancel out with 2, x will cancel out with x. So what we've got on top is x times the square root of 2x all over 4. Now again, at this point, we can't break anything down any smaller, so that'll be our simplest form. Again, you always want to make sure that your denominator, so anything on bottom, there are no square roots, and any square roots that you do have, you can't make them any smaller. If all of that is true, then that is the simplest form you can get. Let's look at example 10 then. We have square root of 4m cubed all over square root of 5m. As we break this down, we have the square root of 4 times the square root of m squared times the square root of m. Now again, we can call this m to the 1 because m squared and m to the 1 makes our m cubed, or our m to the 3. We broke it down so that we know square root of m squared, I can take that out, and this whole thing just becomes m. So that helps us break it down a little bit. Also, we know square root of 4 is actually just 2. So we can simplify that just a little bit. Now, on bottom, we can't really simplify anything. We can't take anything out. So we need to get rid of our square roots. So we need to get rid of the square root of 5 somehow. How do we do that? We multiply the top and bottom by the square root of 5. We also need to make sure to get rid of this square root of m. Now, one trick is we could notice that square root of m is up here, and we could cancel those out and make things nice and simple for us. But let's pretend we didn't notice that and say, okay, to get rid of this square root of m, we need to multiply the top and bottom by square root of m over square root of m. Now again, you can always just cross it out from top and bottom, cancel them out. That would have been fine, but we're going to pretend that we didn't notice that and do times the square root of m on top and bottom. When we do that then, this square root of m matches with this square root of m and just makes an m. So this square root of 4 became 2, this square root of m squared became m, this square root of m with this one became our other m here, and we just have the square root of 5 on top then. Square root of 5 with a square root of 5 became 5. Square root of m with square root of m became m. Now it's at this point that we would say, now I can cross out my m's, which we could have done up here too. Either way would have been fine. And we just combine everything together. So on top we would have 2 times m times the square root of 5 all over 5. And this would be our most simplified form. Again, there are no radicals, no square roots in the bottom, and anything where there is a square root, we can't simplify it. We can't break it down any further. And this will actually be it for our first lesson.